problem 545, boundary or binary tree. So we are giving the boundary of a binary tree. So the definition is the concatenation of the root, the left boundary, the leaves ordered from left to right, and the reverse order of the right boundary. Yeah, actually this description is telling us about how to solve the problem. We just need to plus the root dot value, the left value, and the right side value, and the bottom side value. We just need to plus them together. And for the right side, we just need to reverse the order. Yeah, but how can we solve it exactly? Let's just use the second example. Yeah, because there are more nodes to explain. So we're going to solve it like this. So first of all, we're going to find the root node. So this node 1 is going to be the root node. And then we're going to check the left side node. So what is the left side node? So there's only a node 2. And then we're going to check the right side node. So from the right side, it's going to be 3 and 6. And then we're going to check the bottom side. So the bottom side is going to be the leaves. So the leaves are going to be 4, 7, 8, 9, and 10. And then we're going to connect them together. But for the right side, while we are traversing the tree, we're going to use the pre-order traversal. So it's going to, yeah, let me think if it is a pre-order traversal. Yeah, it is something like pre-order traversal, because for the left side, definitely, it's going to be like a pre-order traversal. But it's not exactly, because for our traversal for the left side, we're going to always choose the node from the left side, but not the leaves. And also, while we are checking the right side, we're going to always check the node that is from the right side. Yeah, because for this node 3, so for example, this node 3 has another value, maybe this is 11. Yeah, so we're going to choose, maybe there's another value, maybe 12 after 11. Yeah, so what are we going to do? We're going to choose the node 11 instead of 6. Yeah, so if there's a possibility from the left and the right side, we can always choose the right side first. So this is like a tree traversal, but it's not exactly like the pre-order, in-order, or post-order traversal. We just have a choice. So if there's one node, it is okay. For example, node 3 and node 6, it is okay. It is from the right side. But if there are two nodes, we can always choose the right first. Only if there's no right side, we're going to choose the left. Yeah, and similarly for this node 2. Yeah, and for this node 2, so we are just starting from this node 2. So definitely for the first node, we're going to choose it. It is 4, and then we're going to have 4 and 5. But if there's a left or right side, maybe this 4 also connected to another node, maybe 12. It is okay. Just an example. So for this node 2, definitely we're going to choose it from the left side. But for this node 2, we're going to have a node 4 and 5. So if there's a possibility to choose, for example, 4 and 5, definitely we're going to choose this node 4. Because 4 is not leaf node. I prepared another node 12 is connected to 4. Yeah. So this is from the left side, and similarly from the right side, and this is the root node. And for checking the bottom node, it's easy. It's just checking the leaves, and we're going to have a condition to check the leaves. So if for this node, it does not have a left and right side, right children, normally this is the leaf node. We just put it inside. Yeah, we just needed to use the pre-order traversal to put the leaves inside the bottom array. Yeah, now let's just try to use this kind of idea to solve the problem. So as I said before, let's first check what is the conditions if there's only one node. Yeah, so this means if not root dot left and not root dot right, because at least we're going to have one node. So I don't need to check if the node does not exist, because at least we're going to have one. Yeah, so if left side and right side both not exist, so we're going to return an array with root dot value. This is important. We have to check it like that, because if there are two nodes, for example, this is a node 1 and this is a node 2, and what is the root node? It is node 1, but what is the bottom node? It's going to be node 2. So we have to find such kind of nodes. So we have to check. Yeah, in this case, actually, yeah. So in this case, because we have two nodes, actually we need to return a node 1 and node 2. Yeah. Otherwise, yeah, I will explain this kind of edge cases later. we have to check it. If there's one node, it is okay. We just need to put this value 1 inside the array. It is okay. But if there are two nodes, as I will use the left plus the bottom plus the right reverse. Yeah, basically I need to use the left plus the bottom plus the right with the reverse. This -1 is just a reverse. Yeah, so in this way, as I will, yeah, I think I need to explain this later, but let's just yeah, I have to check it like that, because if there's only one node, so for example, if there's only a node 1, what's gonna happen is, so for example, if we only have a node 1, it is this node. If I use the left, if I use the root node, it is a 1 plus left, there's nothing, plus the bottom, I'm gonna have a bottom. Yeah, but I should not have the bottom. So this means I have to check it before. If there's only one node, I'm gonna return it. Otherwise, my value gonna be, I'm gonna have a duplicate value while I'm checking the leaves, because if there's only one node, this node 1 is also a leaf. Yeah, but now let me just start coding. If there's any issues, I'm gonna explain it. Yeah, so I'm gonna prepare 3 functions. I'm gonna call it DFS left, which is a node. I'm gonna give a pause at the moment, but basically I'm gonna prepare 3 functions to solve the problem. Definitely it's gonna be 3 DFS. Before that, I'm gonna prepare array, left array, right array, and bottom array. Both of them, all of them, are gonna be an empty array. Yeah. So if everything's okay while I'm running the DFS with, so this gonna be the DFS right, and this gonna be the DFS bottom. So if everything's okay, I'm gonna run the DFS left with the root node dot left side. So I'm gonna start from the left side. I'm gonna run the DFS, and similarly, I'm gonna run the DFS right side with the root dot right. Yeah, but for the bottom, it is okay. I'm directly gonna run the DFS bottom with the root. So this is why I explained if there's only one node, because we are running the DFS bottom with the root, we have to check the edge cases first. Otherwise, we're gonna make a mistake. So after running, if everything's okay, I just need to return the final result. It's gonna be root dot value plus the left side plus the bottom side and plus the right side with a reverse. Yeah. So this is gonna be the solution. Now we just need to finish 3 DFS functions to finish the whole problem. Actually, this problem is a combination of other 3 problems, because in Leetcode we have the problem like binary trees on right side view, and similarly we have the left side view, and similarly we have the bottom side view. Yeah, we have such kind of problem. Actually, this is just a combination. Now let's just finish those 3 sub-problems. And if we finish those 3 sub-problems, basically we solved this problem. Yeah. So for the left side, we're gonna check it must not be a leaf node. So we're gonna check if the node exists and not dot left or not dot right. This is important. Even we have a node, but we are not sure if it is a leaf or not. It must not be a leaf. Yeah. So this means we're gonna check left or right, or both of them. So this is why we're gonna use all. Yeah. So if it meets the conditions, we want to put it inside the left array. So it's gonna be the not dot val. And then we're gonna run the left side first, because this is the left view. So if not dot left, so we're gonna run the DFS with not dot left. Otherwise, we're gonna run the DFS not dot right. So actually, it is a DFS left. Yeah, let me just copy it. Yeah. Similarly, we're gonna copy the code to finish the right side function. So the DFS right, let me just change it to right, and this one gonna be the right, and we're gonna check the if not dot right first, because for the right side view we're gonna check the right side first. If there's a right side, we're gonna run the DFS right with not dot right. Yeah. Otherwise, we're gonna run DFS right with not dot left. Yeah. Now we just need to finish the bottom function. Actually, the bottom function is okay. We are just checking all those leaves, so we're gonna use a pre-order traversal to get all the leaves from the left to the right. Yeah. So if not exist, and we're gonna check if not dot left and not dot right. This means it is a leaf, so we're gonna put it inside the bottom array. So it's gonna be the not dot val, and then directly we're gonna run the bottom DFS bottom with not dot left and DFS bottom with not dot right. As you can see, this is just a pre-order traversal. Yeah, I think that is the entire code. As you can see, it is a lot coding, but everything is just copy and paste. I think from here you can copy everything from the left, right, and bottom. Yeah, and each part of them. Yeah, I mean the combination of the three functions, it may become a hard problem, but if you separate it into three parts, each part is going to be an easy problem, and then you're going to combine them to become a medium problem. Yeah, because this is a medium problem. Now let me just run it to check if it works. As you can see, it works. Now let me just submit it. Yeah, as you can see, it passed all testing cases and it's pretty fast. So the time complexity is going to be O(n). N is the number of nodes. It is 10 to the power of 4. So the hard part may be about the edge cases. We have to check these edge cases first. Otherwise, if we run the function directly, we're going to have a duplicate. Yeah, because this is not root dot value and this bottom, we're going to have a duplicate. And except that, this problem can split into three easy problems. We just need to calculate the left view, the right view, and the bottom view and the bottom side. Yeah, and while we are checking the left and right view, we need to only check the left side node, but not the leaves. So in this code, we just ignore the leaves. This is why we're gonna append it inside the left array. And we're going to run the left first because this is the left view, and if it is the right view, we're going to run the right side first. Yeah, because we can only choose one side. If there's only one side, it is okay, but if there are two branches, we're going to always choose the right side first for the right view and the left side first for the left view. Yeah, I think that's all for it. Thank you for watching. See you next time.